So oxidation-reduction reactions is our second to last unit. And oxidation-reduction reactions are reactions that happen when electrons are being transferred between the reactants. Okay, they are another type in addition to the ones we've already studied. Actually, a lot of the ones we've already studied, like single replacement and combustion and synthesis, are actually types of redox reactions. I never call them oxidation reduction. From now on, we'll say redox. Okay, it's faster, and that's what everybody calls them. Okay, the words in red are what you're filling in if you haven't figured that out. Okay, so in order to determine what is being oxidized and what is being reduced, we have to assign things called oxidation numbers or oxidation states. Okay, mostly I say oxidation state because that's what the way I learned it, but oxidation number is actually correct. They're used kind of interchangeably. Once you know it's the oxidation number, you can see what it is on both sides of the equation and see if it changed. Okay, if it's either gaining or losing electrons. They are similar to ionic charges, but they are not the same. They actually do not have a physical meaning. It is a way for us to basically keep count of how many of electrons are being exchanged. So in some ways, they're like your ionic charge. For instance, if it's a group 1 metal, whatever its ionic charge is, that also happens to be its oxidation state. Okay, it's the non-metals that give us a fit, because they can be all kinds of things, because remember, they're sharing electrons. Okay, so here are the rules for when you're assigning oxidation numbers. Okay, first one is if it's a free element, it is 0. Okay, so if it's a free element by itself, it's always 0. That includes your Brinkelhoffs, which are diatomic, right? So it includes Brinkelhoffs. They are, so if I have O2 or H2, their oxidation number is 0 because they're a free element, and that's the way they exist in nature. They have not exchanged any electrons, that's why it's 0. Okay? The oxidation state of a monoatomic ion, meaning if it's an ion that's by itself, is the same as its charge. So your group 1 metals will still be +1. Your group 2 metals will still be +2. Okay? If it's in a compound, fluorine is always a -1. Always. Okay? So we always give fluorine its -1. If it's oxygen, it's a -2, unless it's a peroxide, and then it's a -1. Okay? I will tell you if it's a peroxide. Okay? Because CO2, it's got 2 oxygen, but it is not a peroxide. It's carbon dioxide. Things like hydrogen peroxide, H2O2, which is what you put on your cuts and not bruises, cuts and whatever, scrapes. Hydrogen is a +1 in covalent, but in metal hydride, that's supposed to be a -1. So change that to a -1. So if I had sodium hydride, which is a metal hydride, sodium would be a +1, hydrogen would be a -1 there. So make that correction in your notes. And then the sum of your oxidation numbers will be 0 if it's an electrically neutral compound, but if it's a polyatomic, it's the sum of the charge on the ion. So we use these things to help us determine what the oxidation number is for things that we're not sure of. So we're going to always be sure of oxygen. We're always going to be sure of hydrogen. We're always going to be sure of fluorine and any of our metals. Our group 1 metals, our group 2 metals, and things like aluminum. Okay? But there's some that we're going to have to go, what is it? And we're going to use these to determine that. So let's practice. Okay. So in this simple one, lithium, what is its oxidations? It is 0 because it is a free element. So it would be 0. In the case of calcium carbonate, calcium is a group 2 metal, so what would its oxidation number be? +2. We don't have to think about that. It's a calcium, it's a group 2, it's going to be +2. I already told you that oxygen is what? -2. So that means we have to figure out what carbon is in this case. Okay? When you see a polyatomic, I personally, you don't have to do it this way, but I personally think it's better to pull out the polyatomic so I can see it better. Okay? So carbonate is CO3 with a 2- charge. That means my oxidation numbers need to add up to a -2 total. Okay? So I know that oxygen is a -2, but how many oxygen do I have? 3. So my total negative charge is a negative 6. Notice that my oxidation number is still negative 2 for oxygen. Because when I'm asking about an oxidation number, I'm asking about the individual element, not all three of them together. So in order for carbonate to equal a negative 2, what must carbon be? Plus 4. So we would say carbon is a plus 4. If you don't know how they got that, you can do a simple, quick, little, easy algebra problem. Negative 6 plus x is equal to a negative 2. And then x is equal to plus 4.
Where did you get the negative 6 from?
We have 3 oxygen, and each oxygen is a negative 2. So 3 times negative 2 is a negative 6. I have something on my glasses.
You get the negative 2 from the top?
I got the negative 2 because carbonate is a negative 2. It's one of your polyatomic ions that you're supposed to know.
Yeah, I just want to make sure that's what
I'm thinking I might need to bring back some nomenclature quizzes because people have not been knowing their polyatomics today.
I just want to make sure that
Oh, David wants them. They're going to yell at you, David.
Yes. It used to be an easy quiz, right? Then we made them harder.
Okay,
We love you.
so let's do some practice here. Okay, KMNO4, potassium permanganate. Okay, so let's go potassium, manganese, and oxygen. Potassium, group 1 metal, so what's going to be its oxidation number? It says practice. I think I have different ones than you.
Yeah.
Good, because I want you to practice the other ones. Okay, I will tell you a little secret. You have homework, right? It's not really homework if you don't want to do it. I am not going to take it for a grade. It is practice work. However, we're having a quiz on Monday. Okay? So if you get this after we're doing this and you're like, man, I got this. This is easy. Don't do the whole worksheet. If you feel like you need to practice it, then do the whole worksheet. It's practice. Same thing with the section section that's in the notes. Practice. Okay? I'm going to give a quiz over it. All right, so oxygen, we said, this is not a peroxide, so oxygen's what?
Negative 2.
Negative 2. So we have to figure out what manganese is. So permanganate was one of your ions. Looks like that. So I have 4 oxygens, so what is my total negative charge? Negative 8. So what does manganese have to be equal to a negative 1, the overall thing?
7.
Plus 7.
Can you explain how you got the negative? If it's just a negative at the top.
I'm talking about my charge of oxygen is a negative 8 because I have 4 of them. So this is a negative 8. We're trying to figure out what the charge of that is. The overall charge is this right here. So overall, I say negative 8 plus whatever that is got to be equal to a negative 1. The whole thing has to be 4 times negative 2.
Why is there just a negative at the top?
Because the whole thing has a negative 1 charge. The entire thing is it's covalently bonded together. The entire thing has a negative 1 charge. Within that negative 1 charge, I know that oxygen is a negative 2, and I have 4 of them. So 4 times negative 2 is negative 8. So I'm trying to figure out what does manganese have to be so that the overall thing is equal to a negative 1. Oh, thank you.
You're welcome.
Thank you, thank you. Okay, so that made it a plus 7. Yes?
On the quiz on Monday, will you get to have the rules or no?
Nope. But if you do this whole worksheet, by then you'll know those rules. Yeah. Okay, so now let's do sulfur trioxide. Okay, this is sulfur trioxide. This is sulfite. They are 2 different things. They are bonded together in 2 different ways. Those I caught you on one of the nomenclature quizzes. Do you remember? Most of everybody missed it because they said SO3 was sulfite. Without a charge, it's not an ion, is it? Okay, so let's do, let me erase this. So for SO3, we're going to do sulfur trioxide first. Sulfur oxygen. Oxygen negative 2. Okay? But I have 3 of them. So what's my total negatives within there? Negative 6. So that means sulfur has to be positive 6. If I do this now in sulfite, Oxygen's still a negative 2. Still have negative 6 total, but what does sulfur have to be in order to equal the overall? That's right, plus 4. Because negative 6 plus x is equal to a negative 2. So that means x is equal to plus 4. That's the algebra for those of you that just don't see it right off the bat.
Ms. Parker, what's the answer for SO3? Sulfur trioxide?
It's right here.
Oh, there.
Why is it that they add up to 0?
They're bonded together different. This is a polyatomic ion, so it's covalently bonded with the charge. The other one is just a covalent compound.
So it's only when it's like with the potassium or the permanganate that we did before. The last one we just did.
What about that one?
That one we had to add it up so it would equal oxygen. Like, is that what
It wasn't equal to the oxygen. It was equal to negative 1 on MnO4 because that has its charge.
Right, but we're trying to get it to be even. Or what number are we? What's our number?
Yeah, like what are we trying to get to on the top one?
Yeah, what's our number that we're trying to get
0. It's neutral. There's no charge on it, so it's neutral.
So we're trying to make it neutral.
Yes.
Okay, there we go. Iterate that.
And the other one, we're making it,
So every single one we're trying to make it neutral with oxygen.
no. We didn't on this one. We had to make it a negative 2. We have to make the whole thing equal a negative 2. You have to equal the charge because that particular item has a charge.
So if it doesn't have a charge,
If it doesn't have a charge, it's neutral. Yes.
if it does, you try to make it whatever number is above.
Correct.
Okay.
So now let's do SO4, which is a 2 minus. So sulfur, oxygen. Oxygen's a negative 2. I have 4 of them. So it would be plus 6 because this would be a negative 8. So I need a plus 6 to make the whole thing be a negative 2. Okay? Let's do 1 or 2 more because I feel like y'all are still struggling. Okay, on your paper, mark out the CaCO32 on your paper because it's wrong. Okay? And let's do this one. I want you to, you have to make a change because there is a typo. Was it 2? CO3, no. Outside should be a 3, not a 2, because that's not, so it should be this.
Yeah, the one we have the third one.
It's the third one. Huh?
CLO, not
Oh, CL. There we go. Now there's an L in there. Okay, so aluminum, chlorine, oxygen. Aluminum is a plus 3, oxygen's a negative 2. When you have a polyatomic ion, it makes your life easier to pull it out and just do it by itself. Because if you've got all those exponents, then you're starting to add up other things. It just makes it more complicated. So that is chlorite, okay? Has a negative 1 charge, okay? So that means I have right now a negative 4. So it's got to be plus 3. It's easier to pull out your polyatomic ion and do it by itself to figure out what that other thing is. Okay? Yes? Yeah. I mean, I can show you how to do it in the compound, but it's much more complicated. Yeah, it's just easier to pull it out.
4, that's how many oxygen you have. So
You have 2 oxygen.
Subscript 2 by negative.
Oh, negative 2 times 2 is 4. Sorry, I need to go back to preschool.
Ms. Porter, I also had a question. For where you write where you wrote oxygen negative 2, why would it be negative 2 and not negative 4?
Hey, guys, I'm recording. Shh, I'm recording.
Why would you have oxygen negative 2 instead of negative 4?
Because together it's a negative 4. Its individual oxidation number for each one is a negative 2.
Okay. That
Yeah.
makes sense.
Never put the total there. Always put what it is individually.
Okay.
Okay?
So it's going to be important for us to study over nomenclatures that way we know what the...
I mean, you could figure out what the charge of that was if you didn't know it, because you know that aluminum is a plus 3, and it took 3 of those chlorates to go with it, so you could figure out that it was a negative 1 charge, even if you didn't remember it. Okay, and then let's do, while we're here, let's do this one. Let's do one more. Well, let's do this one. AgClO, that's the next one. Silver is +1, always +1. Oxygen, -2. So we have ClO minus. So we have a -2 here. So what does chlorine have to be? +1.
Because it's 0. You're trying to
Well, you're trying to get to a -1 there. Okay? So do we feel semi-comfortable? I can't hear you.
Why do you know oxygen Ag alphabet, but you don't know chlorine?
Because from the rules, it says, rule number 4, oxygen is a -2. Then that's how we know.
But how Ag?
Ag is a monoatomic ion. It's the same if it's normal charge.
Oh,
Rule number 2.
Oh, the COs inside that CO. Oh,
Yeah.
That's why you don't know CO.
Yeah.
Oh, okay.
Typically, the ones you're going to have to find oxidation states for are nitrogen, sulfur, chlorine, bromine, and some of your transition metals.
Are they in the middle, like always like this, or what?
Well, I mean, that's the ion. It's just the way it is. Okay? Yes?
Okay, so for this worksheet then, are we going to be given the answers on Monday?
Yeah, I'll put the key up. When you walk in, the key will be up. Okay? All right, so now let's talk about what redox reactions are, now that we can assign oxidation states. Okay? First of all, we write them as half reactions. They always occur simultaneously. You cannot have an oxidation without a reduction. No exceptions. Okay? You have to have oxidation and reduction happening simultaneously. One doesn't happen before the other. They happen simultaneously, always at the same time. Okay? Oxidation is the complete or partial loss of electrons. When the element is losing electrons, its oxidation state will become more positive. Okay? Even though it's losing things, some people get that backwards, but the things that they're losing, what are they charged-wise? They're negative. So if I am a negative person and I lose my negativity, don't I become a more positive person? Okay. Okay? In theory, yes. If it's a reduction, it is the complete or partial gain of electrons. And when they gain electrons, their oxidation number or state will become either less positive or more negative. Depends on how you want to look at that. Yes?
So I was wondering, does oxidation have anything to do with oxygen? Or is it that?
It does. It does. But I mean, that's just one thing that can be oxidized or reduced. But that's where our term originated from. Because oxygen gas tends to cause something else to be oxidized.
Oh.
Yeah. Okay. So let's look at a simple synthesis reaction of sodium and chlorine making sodium chloride. Okay. Sodium is losing electrons, so it's going to be oxidized because it's the loss of electrons. Okay. Chlorine is going to be reduced because it is gaining electrons. Okay, so that's how we would write the half reactions. We break them out and say this one's doing this one's doing that. That's our half reactions. Okay, then we put them together to get the overall redox reaction. We will balance redox reactions next week. They are a little like a puzzle. They're my favorite. I love them, but some of you will not. But I love redox reactions. They're my favorite. Yeah. Okay. Okay. So, easiest way to remember this is oil rig. We don't use Leo the lion goes grr because we're Texas and we like oil, so it's oil rig, which stands for oxidation is loss of electrons, reduction is gain of electrons. Oil rig is a very famous acronym within the chemistry world. Helps you remember which is which. Oxidation is loss, reduction is gain. Okay? This unit is full of acronyms.
Oh, great.
Okay, so take notice about oxidation number changes, okay? If you're looking at a reaction and I'm asking you to determine if it's a redox reaction or not, you have to assign everything their charges or their oxidation numbers because you have to see if there's a change. If there's no change, then it's not a redox reaction, okay? It's not. For instance, acids reacting with bases, Not redox. Nothing changes its oxidation number. It stays all the same. Okay? Synthesis reaction, almost always a redox. Anytime you see something that is a free element on one side and it is bound in a compound on the other, you can bet your bottom dollar that's a redox because it's going from 0 to something. Okay? So if it's got a free element on one side and not on the other, that's a redox. You can take that to the bank. All right. Let's talk about the agents. Okay? Reducing agent is the substance that loses electrons in a oxidation reduction. Okay? So it causes it to, wait, let me start over. The reducing agent is oxidized, meaning it lost electrons. But it causes the other thing to be reduced. So we call it a reducing agent. Okay? The oxidizing agent is the substance that's reduced, but because it's reduced, it causes the other thing to be oxidized. So we call it an oxidizing agent. So they're kind of like opposites, right? Because you can't have one without the other. So whatever is oxidized causes the other thing to be reduced. We call it the reducing agent. Okay? There's a little picture at the bottom of your thing that kind of shows you that. So going back to our sodium and chlorine example, we said that sodium was oxidized, so that makes sodium the reducing agent. We said that chlorine was reduced, so it is the oxidizing agent. In other words, chlorine causes sodium to be oxidized. So they're opposite. Okay? So we're going to do some examples. All right, ready? So if you turn to the next page, it says practice problems. We're going to do this one first because it's an easy one. Magnesium plus oxygen, the arrow got left out, is MgO. OA and RA is how I designate oxidizing agent, reducing agent. Now, in order to determine what's being oxidized and being reduced, you don't even have to balance it. It's not necessary, okay? Because we can still see their change in oxidation states, okay? So magnesium and oxygen, both free elements, so what are they? 0 and 0. Magnesium is a group 2 metal. What is it going to be? +2. Oxygen is -2. So, oxygen and magnesium. What's happening with magnesium? It's going from a 0 to a +2. What did it do? It lost electrons. How many? Lost 2 electrons. No, it's being oxidized. So magnesium is being oxidized. That will make it the reducing agent. Oxygen is going from 0 to a -2, so it gained 2 electrons. So oxygen was reduced, and it was the oxidizing agent. Because oxygen caused magnesium to be oxidized, so it makes it the oxidizing agent. It's the agent of change. Okay? Let's do another one. I mean, unless y'all are good with that. Yeah, I think y'all need one more. Actually, I think you need a couple more. Okay. On that same page at the top where it says SO2 plus H2O is H2SO3, mark it out. It's not a redox. Because everything stays the same. So we're going to do this instead. So mark that out and we're going to do calcium chlorate being decomposed to make calcium chloride plus oxygen. Okay. So calcium, let's do that one first. What is it on both sides of the equation? +2 +2. So should calcium appear anywhere in this bottom part? No, it's unchanged. Okay. Actually, it's going to stay as a spectator. Oxygen is a -2 here, right? What is it over here? 0.
Losing electrons.
Very good.
Why is it 0?
Because it's a free element.
Oh.
Okay? So chlorine, we have to figure out what its charge is. Remember chlorate, ClO3 minus? So minus 6 total, so what does it have to be? Plus 5. And over here, what is it in that compound? No, it's not a negative 2. Minus 1. Thank you, Lucas. Because you were close when you said minus 2, except there's 2 chlorines. So it's a negative 1. Yeah. Okay? So it's going from a plus 5 to a negative 1. So oxygen lost 2. So it is oxidized. So we're going to say O2 minus is oxidized, not O2, because O2 is already on the other side. Okay? And then we're going to say the chlorine plus 5 was reduced. Now, when we're talking about what the agent is, technically, the oxidizing agent is the whole thing, as is the reducing agent, because you can't just isolate out the Cl5 plus, or you can't just isolate out the O2 minus. So technically the whole thing is the agent. However, if you on a test said O2 minus, not back there. If you, however, said this was that and this was that, I would probably give you credit. But technically it's the actual compound, the whole compound. Okay? Let's do one more. And then we'll...
How did you get for, on CaCO2, how did you get a negative 1 for Cl2? Is that because it's a free...
Well, calcium chloride. Calcium's a plus 2. That means this side has to be a negative 2, but there's 2 of them. Negative 2 divided by 2 is negative 1. And in this case, it's a monoatomic, and it keeps its same charge. Because that's normally a monoatomic chlorine is a negative 1. Now, Megna, do you see why we don't do this when we're doing ionic compounds? We wait. Yeah. The book actually does the oxidation states at the same time as we do charges with ionic compounds, and I'm like, Ed, no. It would be a disaster. Okay, let's do one more, and then I'm going to turn you loose. Let's do magnesium plus sulfuric acid is going to give me magnesium sulfate and hydrogen. What kind of reaction is that? Single replacement. Okay? So sulfate's the same on both sides, right? SO4, SO4. So do I need to worry about sulfate in this case? I do not. Because it's not changing. 0 to plus 2. It is losing, so it is... It is oxidized, which makes magnesium the reducing agent. What is being reduced? Hydrogen. It's going from a plus 1 to a 0. So it gained 1 electron. Whoops, gained has a D on it. So H plus is being reduced. What's the oxidizing agent? H2SO4. The whole thing, right? But if you just put H plus, I would probably give you credit. Okay? All right. Any questions before we go practice?